Okay, good evening, good morning, good afternoon, everyone. Those who are listening to my lecture. So in this session, we are going to discuss an important part, that is regression. Regression is a part of our unit number 2 as well as unit number 3. First of all, we are going to see what comes in unit number 2. In unit number 2, there are two types of regression that we are going to mainly study. The first one is multiple linear regression, and the second is polynomial linear regression. And in unit number 3, we have a topic logistic regression. So the first, like we are going to discuss, is what is regression. Okay, so to start here, we are going to start. Wait a minute. Okay, much better. Okay, now suppose we have we have to find the cost of laptops. Okay, and this is one data that we have to find, and the other data that we are provided is the storage of laptops. Now consider this as y and consider this as x. Now if the cost of laptop is high, generally the storage would be increased as the cost will increase of a laptop. Now this we can predict the value of a storage by simply by understanding the cost of a laptop. So we can plot a graph here. Consider this axis as y-axis, that is cost of laptop, and consider this as x-axis, that is storage of laptop. Now when the cost of laptop is low, the storage of laptop would be less. Okay, and when the cost will increase, the storage will also increase. Okay, so somehow we will get a regression, that is we will this so we if we make a line here, so this line is a linear line and we call it as linear regression. Regression is nothing but the production of values from a given variable. Okay, we correlate two variables and we predict the value of that element. So for example, if we have to find the storage of a laptop, we can easily, not easily, but somehow predict the value of, the storage of a laptop by the cost of the laptop that the company is providing us. Okay, so wait. So we have seen what is regression. Regression is a statistical method which allows us to predict dependent output variable based on the independent input variables. So what is output variable here? Sorry, independent variable in this graph. Independent variables is x. Wait a minute. Okay, so independent variable here is x. The storage of a laptop does not depend on anything. This variable does not depend on the whether the cost of laptop is high or low. Actually, my example is not very proper here, so you can't relate to what I am trying to explain, right? But consider that x is an independent variable. It does not depend on anything. Whatever you consider x would be an independent variable, whereas y would be a dependent variable. So as of definition, regression is a statistical method which allows us to predict a dependent output variable based on the values of independent input variable. So see the graph here. The y-axis is the prediction value that we are predicting based on the data. This data is given. This data is already given to us. Now we this y-axis is a dependent variable. We find this variable based on the input variable, that is independent variable x. Now this statistical method is called as regression. Regression is nothing but the prediction of variable. To be more specific, prediction of independent variable. So we have seen what is regression here. Now we will see what is simple linear regression. Simple linear regression is a machine learning model that is used to predict the values of input uh, dependent output variables based on the values of independent input variables. The definition is same as the regression, but the only thing here is here we draw a straight line, that is linear line. Now x is considered as input variables and y is considered as output variables. We can see here the input variables x are independent variables and so on. Regression is used for cases where we predict some continuous quantity. Okay, the quantity is continuous. If the price goes up, the storage will also go up. Okay, see price and time here. The author has written some other example, I think, for uh, predicting stock price. Okay, so the price increases, the time also increases of a stock management. Okay, stock reduction. This is actual price and this is predicted price. Okay, the line that is drawn is predicted price and the actual price is here. We take the average of this, and this line comes no, k nearest. I thought it was in k nearest, but k nearest is a complete different concept. Okay, so here the formula is given and we have to write this formula. I will explain you for the formula here. Okay, so let's consider this example here. Now y-axis is the height of students and the y-axis is the weight of students. Now y-axis depend is an output variable that is dependent to x. If the weight of student increases, the height of the student will increase according to our machine learning model. So to find this out, to find y, we have a formula that is y is equal to mx plus c. Now what is m here? We'll see. Okay guys, so what y stands here is, y is what we are going to find, and what are we finding is the output. Output is a dependent variable, and the m here is the slope, and the slope of this line. And how we find the slope of this line is a uh, 10 10 theta. Okay, this is the formula of finding the slope of line, and m here stands as the slope of the linear line, whereas c is the intercept of y. The difference between the slope of line and this zero, the y 0 of y-axis is the c here that we are going to find, and by for solving the equation we will find the output of y. Now x here is the independent variable, so we are going to add independent variable and then we are going to find the y. Whatever x would be, based on that x the y would be keep on changing. So this, the idea of simple linear regression is that when only a single independent variable is taken as in relationship with a dependent variable, we call it as a simple linear regression. So here, as we have seen the example, the height of the students and the weight of the students. So the weight is only a single variable that we have taken in account to the relationship with y-axis. So this is an example of simple linear uh, regression. It's a very simple example that we can write in an exam, and it's a very valid example. So you don't have to worry about it. So we have seen simple linear regression, right? The importance of simple linear regression was the formula. So now we understand the formula, we can easily make the formula of multiple linear regression. Now we will see what is multiple linear regression. So there is one section, slope of linear regression, but don't read about it. Just you should know what is slope and nothing else. It's a waste of time here. Uh, we are seeing now is applications of linear regression. You can read this: evaluating trends and sales estimate, analyzing the impact of price changes, estimate of risk in financial services and insuring domain. So all this thing is dependent on one variable, and based on that dependency we can find the independent variable. Right? See, sold quantity as an independent variable and price as the independent variable. Advantages we can write about linear regression, but this all is not important. The topic that we have in the unit is multiple linear regression. See, is it is an extension of simple linear regression, as it takes more than one predicator variable to predict the response variable. It models the linear regression with a simple single dependent continuous variable and more than one independent variable. The multiple linear regression depend the dependent or target variable must be continuous, real. There's this, you can read this all. Actually, I don't know why the images are not loading. I'll just search and show you. See, where is the image at? This. See, now the here example is something that based on the heart disease. If diseases are taken as output here, output variable, that is dependent variable. It is dependent on three, I think, two variables. The first one is bike biking to work, and the second is smoking. Now, if you are smoking, then you will have a high rate of heart disease, and if you are going by bike to work, then you also have a high rate of disease rate. So this is what it shows. But don't just look at it. But it is not a very good example. I will take another example for this. Okay, guys, so the topic that we were discussing was multiple linear regression. Now, look at look at an example that we have taken before, that is considering the prices of laptop. You have to find the price of a laptop that is on y-axis. Y-axis is a dependent variable. Now, based on multiple variables, independent variable, we have to find the cost of this laptop. Now, the first one that we have taken was the storage of the laptop. Now, the second one that we are going to take is the display, sorry, the RAM that the laptop is providing us. Okay, so the storage is taken and we are taking RAM. So now there are multiple independent variables. So this, while taking multiple independent variable to find an output that is dependent variable, we call it as multiple linear regression. We will see the definition in the notes here. Multiple linear regression is an extension of linear regression as it takes more than one predictor variable to predict the response variable. It models the linear relationship between a single dependent continuous variable and independent more than one independent variable. This is the highlighted point here that makes the difference between a single linear regression and multiple linear regression. The concept is easy, very easy. We will not waste time here. uh, just write an example of laptop that I have shown you, or you can read this out and you can use this example as well. Both the examples are valid, correct. We will read this point. The dependent or target variable must be continuous or real. Now, this is a property of simple as well as multiple. The the variable dependent variable y should be in continuous form and real form. Okay, not in up and down. But even if the storage of laptop goes high, the y will fall down. Okay, this shouldn't be the case. Now, how the diagram will look here? So look at this example here. The diagram would look something like this. Now x1 and x2 here are independent variables. Consider x2 as the storage capability of our laptop, whereas x1 is the RAM of our laptops. Now, if this looks like a 3D figure, okay, so this might go a little hard to draw in the in the answer sheet. So you can always go with another example. For example, you can go with this example. This is much better. We can draw the three lines, and all other examples also show this only. See, linear, multiple. So you can go with this example, but the actual figure would look like this because there is two variables, that is the storage capacity and the RAM, and this y-axis is for the cost of the laptop. Now, linear, we will see the formula of this expression. So this is the what was the formula for simple m, even I forget it, mx mx plus c. Now x was the slope of line. I think x was the slope of line. Slope of line, na? Wait a minute. Here x was the slope of line, and the slope of line will be the will change according to the variables. Now if there are two variables, right, x1 and x2, so the y is equal to mx1 plus m1 plus x1 plus m2 into x2 plus c. Now c would be the constant here, that is in interrupt of y, whereas m1 and x1, m1x will change according to the number of variables. So the formula goes like y is equal to m1 x1 plus mn xn plus c. Okay, so this would be the formula for multiple linear regression. Now we have seen multiple linear regression. We will move to our next we'll move to our next topic, that is polynomial regression. We'll see what is polynomial regression. Okay, polynomial regression model is extension of simple linear regression model by adding extra predictors obtaining by raising square each of the origin. See here. Actually, first see the I don't think I have a multiple linear regression formula. Now see this equation here. The x is not changing here, but the slope, that is b here stands for slope, but the b here is always changing. B here is changing, and the x is just getting square. See, x1, x square, x cube, and so on. So this is what the polynomial regression looks like. If the data set. Okay, so our topic that we were discussing was polynomial regression. Now let's consider a problem of simple linear regression. We draw a graph. Okay, now we have y-axis, we have x-axis. We have only one independent variable for a dependent variable, no problem. But what if y is not continuous? It goes up and it goes down and up. Now this is a problem that simple linear regression cannot handle. So we need is some solution for this. It is substitute for simple linear regression. Simple linear regression and multiple linear regression is a linear regression. It goes on a straight line. It will not take curves or something, some other shape. It will only predict if the data points are in a straight line. But if y is not continuous, it does not only goes up, it can also go backwards. So we need some substitute for this, and for this reason we have polynomial regression. Okay, polynomial is not a linear regression, it's just a regression. The only thing we do here is we just take the square, we keep on raising this predictor, that is this independent variable. The same variable we take one to one correlation, one to one relationship, that is one independent variable related to one dependent variable, and we keep on raising the independent variable. That is, we first take the square of this, squaring by squaring, and then we take the cube of this and so forth. Okay, I will go through the notes and then you will understand it more clearly. Sorry. Polynomial regression model is the extension of the simple linear model. Okay, it's an extension, it's just an improvement to the simple linear model. by adding extra predictors. Okay, extra predictors. What is predictors? Predictors are nothing but independent variable that is x, obtaining by raising squaring each of the original predictors to a power. Okay, raising each of the original predictors to a power. We keep on raising it by first we have a single x, then we raise its power by 1, that is 2, and then also by 1, that then it becomes 3, and so forth. Now if we raise this power, we will have a different slope of line. Okay, then if we have a different slope of line, we will have a different m or b. Okay, m or b, see the formula here. This is the formula. Y is equal to b0 b1. Now b1 is the slope of the line that we are going to make. Okay, see, I will read this. In the above equation, n are the coefficient. Polynomial regression is a regression algorithm that models the relationship between dependent y and independent x as the ninth degree polynomial. This is the equation. It is a linear model with some modification in order to increase the high accuracy. Okay, it is a linear model but with some modifications. Now this statement is an important statement. The dataset used in polynomial regression for training is of non-linear nature. It makes use of linear regression model to fit the complicated and non-linear functions and datasets. Okay, it uses the linear regression model to fit complicated and non-linear functions and datasets. We uh, we train this regression model. Okay, now this model is going to be trained on a non-linear data set, but it it was a failure when we use a simple linear regression. See, if we apply a linear model on a linear data set, then it provides us a good result as we have seen in the simple linear regression. But if we apply the same model without any modification and non-linear data set, then it will produce a drastic output. So this was an error here, that we have found the solution by polynomial regression. And what is polynomial regression? It is nothing but a simple regression that takes by adding some extra predictors by raising obtained by raising each of the original predictors power to a power. Okay, we if you read this, we will see an example here. Let's see an example of, see this line. As you can see, polynomial regression degree 2, degree 3, till the degree 3. See, this is the equation. C0 C1, this is what it takes to find the regression of this polynomial. This is what the polynomial regression is meant to find. It is in a curve, not a linear line. So it is called as polynomial regression. So now we have discussed three concepts. So up till now we have seen three types of regression: simple linear regression, multiple linear regression, and polynomial linear regression. The last one is logistic regression, and it comes in unit number 3. But we are going to see it in this session only. Okay, so guys, we are now going to study logistic regression. So as we will start with this with an example here. Consider y-axis and consider x-axis. So y-axis stands for if the human is if the human has diabetes or not, and the x value stands here as the weight of the human. Now there are only two probability in y-axis, that human has diabetes, that is yes, and human has no diabetes, that is no. And then there is no third probability, that they don't have, just they have only two probabilities, that is yes and no. So x here is an independent variable, and it says the weight of the human. So if the weight of the human is less, we have a probability of that the person has no diabetes. Okay, but if the weight increases, the probability of having diabetes increases. Now as you can see, we will draw a line that will cross all the data points. Okay, it will go something like this. Okay, don't draw a straight line, something curving line that will say S. And S, the line S here is sigmoid function. Sigmoid, I don't know, am I pronouncing it right or not, but it is somewhat sigmoid function. Now this example of classification of data points into yes or no is called as logistic function. Simple as that, this is logistic function. Now the main reason why this logistic regression is in unit number 3 is that unit number 3 stands for classification, and logistic regression comes under regression as well as classification, because it classifies uh, a data point into a group of data points, that is either yes or no. It classifies them into data points. Now we will see the notes here. What does the notes says about logistic regression? Logistic regression is one of the most popular machine learning algorithms, which comes under supervised learning. It is used for predicting the categorical independent variable, dependent variable using a given. See, this categorical is important here. It is used for predicting the categorical dependent variable from the given set of independent variables. This is an important part. It is used to find categorical. Yes is a category, no is a category. Uh, for example, to predict whether an email is spam or not, tumor is malignant or not. Logistic regression is both classification and regression technique depending on scenario based. See, I told you before that it can be both logistic as well as classification, and the reason behind that it comes under classification chapter is this only. Logistic regression is a type of regression analysis used for predicting the outcome of a categorical dependent variable. Okay, this is important. It is used for categorical dependent variable. Now, it y is in binary 0 or 1, and independent variable are continuous in nature. They are continuous in nature, as we have seen in the example. Weight of human increases, it is continuous, not any category or something. Just go through this. This is an important point in logistic regression. Instead of fitting a regression line We fit S-shaped logistic, that is, sigmoid function which predicts two maximum values. The sigmoid function is a mathematical function used to map predict values, and you can write about sigmoid function. The curve from the logistic indicates likelihood of something. You can also write this. See, this is an example. A mouse is obsy or not. Obesity. A mouse has an obesity or not. We can find this based on its weight. Okay, now see this example. If a human lies here on y-axis, if a human has a weight of something here. Now see this. So this is less than 50%. So the probability of human doesn't have diabetes is greater than it has diabetes. This is what the reduction of logistic regression means. This is the reason why we are using logistic regression to find the prediction of a categorical data. Either it is something or not. Logistic function, this is not important. Independent variable must be categorical in nature. This is important. Now you can always learn the formula. This formula is, I think, same as multiple linear regression. So you can use that also. But moving further, the important thing is that you can also write in paper is the type of logistic regression. So there are mainly three types of logistic regression. The first one is binomial type. Binomial is by, that is 0 or 1. Okay, it will have a category of only two, that is yes or no. While multinomial type, okay, multinomial logistic regression, it will have three or more types, but in unorder sequence. Okay, it will not be in sorted sequence. Whereas ordinal linear logistic regression will have more than three or more than three, but in orderly sequence. So these are three types of logistic regression. And the next topic we are going to cover in next unit, that is k nearest neighbor. These are all classification methods: k nearest neighbor, naive Bayes decision tree, SVM recommendation system. So this two three things are very important: k nearest, naive Bayes, and decision tree, that we are going to see under in our next session. Now we are going to take a revision here. So what is regression? Regression is nothing but the classification. Is statistical method to find a dependent variable based on the independent variable. Prediction of a output dependent variable based on input independent variable. Now there are certain methods for this. So we are going to see simple linear regression. In simple linear regression, we take only one independent variable for a dependent variable, and then we predict the value of dependent variable. We can use example, uh, whatever you want. We have discussed in the session. Multiple linear regression is where we can take type multiple independent variables for a single dependent variable. Now these two are in form of continuous input values, and the data that is given for for them to train is a linear input. But when the linear input is not in the training data set, we use polynomial regression, where we just take the simple linear regression predicators and add some extra additional predicators by raising the power of the already existing predicators is called as polynomial regression. Now then we go with logistic regression, which can also come in classification method, where we classify a data point into categorical data. A category We take categorical dependent variable that is used A independent variable that is used to find categorical dependent variable is called as logistic regression. It comes in yes or no. There are three types of this, and it will make a S-like curve, which is called sigmoid function. So these are some important concepts in regression. If you read the notes once, you will understand everything, and it will become very easy for you to write in paper. So thank you everyone. This is the last session of today, and tomorrow we are going to discuss unit number 3 and all the remaining units in detail.